Welcome back to the next video in Unit 1. As you can see in this video, we're going to look at the internal coding of text, or effectively how we represent text in our computer. Right, so video overview. Well, first we're going to look at the two different character sets that are commonly used. Right, one is going to be ASCII, one is going to be Unicode. And just quickly, ASCII is going to be either 7 or 8 bits. Right, therefore that gives us 128 or 256 different characters. In contrast, Unicode, well, that's going to allow us to support kind of all the characters in the world. We're going to look at our standard versus extended ASCII again, right, 7 versus 8 bits. Right, then we're going to look at UTF-8, UTF-16, UTF-32. When it says 8, this is just the different number of bits. Now, actually, UTF-16 and UTF-32, okay, these are going to be fixed size. So UTF-16 always uses 16 bits, right? UTF-32 always uses 32 bits. But if we look here at UTF-8, well, actually, UTF-8 is going to be variable size. So it's going to use between 8 and 32 bits. That's a terrible 32. Okay, writing with the mouse pad. Right, then we'll just look at some ASCII codes of some common characters like 0, big A, and small a, and of course how we can use that to derive other, letters and numbers. And then we'll also look at why some languages and some characters like emojis use more storage space than others. Right, so as mentioned, everything in a computer has to be stored as binary, right? Whether that's numbers, images, video, sound, text, right? Programs, everything is stored as binary. Right, therefore we need a representation of characters in binary, and two that we have. One's going to be ASCII and later Unicode, right? And these we're going to call character sets. So a character set, right? A key definition they often ask in an exam. This is a collection of characters whereby each character is represented with a unique binary code. Let's just see that if it doesn't make sense. Right, so the first character set we'll look at is going to be ASCII. It's going to stand for the American Standard Code for Information Interchange. Honestly, right, that's not kind of relevant. It's going to be standardized by ANSI, right, the American National Standards Institute in 1963. And actually, I think ASCII, they've been using this for, maybe 100 years, right, maybe more. Pretty much I guess kind of like the same time as Morse code. They were kind of using it at the same time. Alright, so there's going to be two versions. One is 7-bit or standard ASCII, and there's also going to be 8-bit or extended ASCII. Right, every bit pattern is used to represent a character. Right, therefore, how many characters could be represented, or would be represented, right, by both versions? So of course here we just want to think, if we're using 7 bits, of course that's going to be 2 to the power of 7 different characters. Right here, of course, 2 to the power of 8 different characters. We can say standard ASCII gives us 128 different characters, while extended ASCII gives us 256. Off topic, but probably people have seen ASCII art, and maybe people have actually heard this term as well. And of course, the reason it's ASCII is because, obviously you're making this artwork, right, using just the common characters on your keyboard. Now, I guess technically, you could actually use other characters, let's say, some emojis or some other things. Technically that wouldn't actually be ASCII, right, because, I suppose in that case, right, that's going to be using Unicode. And the reason for that is because if we say, here ASCII can only represent up to 256 characters. So things like emojis, okay, they're not going to be included in ASCII, right? They're going to be in the Unicode character set, which we'll see in a minute. And then if you actually look at this photo, right, if you zoom in, then actually everything here is just, just zeros and ones, right? There's only 2 characters in this entire image. Okay, so if we look at some of the character codes in ASCII, first there's going to be 32 non-printable ASCII characters. The range 0 to 31. And here I'm just showing 13, although of course, if you want to see the full list, right, just go online. So some of the common characters, let's have a look. I suppose one is going to be the null character. So where are we? Right, null character. Basically that's just going to be nothing. Now in some languages, let's say for example C, right, strings are actually terminated with a null character. So let's say if we look at this in a minute, 65 is going to be big A. Right, 66 is going to be big B, and then 67, right, that's big C. So then what you'd have, and then I guess you just go 0, 0. So we're saying, right, this is going to be the string. Hang on. Right, let's go back. Okay, right, that's going to be all the string. A, B, C, like that. And then we say, when we have 0, 0, okay, this means it's the end of a string. Right, and I guess, yeah, other ones, I mean, I guess backspace, okay, here we go. Yeah, where's the pen? It's difficult to, okay, yeah, here we go. So of course, backspace, everyone should know this, right? Just the backspace key on their keyboard. I mean the tab, again, people should know the tab key on their keyboard. Right, when we say line feed, I mean, this is basically the enter, right? This is just the new line, right? The enter key. Yeah, I mean, character return, this is kind of like resetting the cursor at the start of the line. So if we actually look, this image shows the data, I guess, yeah, the data when an email is sent to an email server, yeah, probably via SMTP, right, the maybe send message transfer protocol, yeah, like possibly that, or yeah, I mean, possibly that's wrong, but again, that's just going to be it's going to be a protocol for sending emails. So if you can see, I mean, probably here you can notice the subject, also the CC, so I think the carbon copy, and yeah, also the body. Well, so of course, yes, subject, okay, here we go, right, subject, that's easy to see. I think the CC, yeah, maybe it's going to be this C and then maybe this C, and then I guess, yeah, the body just here. And then something else to note, now actually, you know, for the exam you don't need to know this, but yeah, maybe it's interesting, and actually if you're programming, you know, in real life, right, then, well, this pattern, I mean, you're going to see all the time, right? Let's say when you're reading from files, well, when there's a new line in a file, right, yeah, that, I mean, you're going to get these characters at the end of a new line. Now, actually, different operating systems actually have different characters. I think, I guess, the character return and line feed, like, maybe that's just going to be on Linux, or yeah, like, I don't know, maybe Windows, I'm not sure. Whereas, of course, right, Windows or maybe Linux, right, one of them is just going to have the line feed, right, one of them is actually going to use both of them to define a new line. Now, I think Mac is similar, right, maybe Mac does something slightly different as well. Right, I guess STX, right, the start of text, right, then, yeah, SOH, right, the start of heading, right, something called GS, group separator, and, you know, to be honest, I mean, these are actually, yeah, like, not really used, to be honest, or I suppose, okay, well, like, when I say not used, I mean not common for sort of, yeah, like, normal, I guess, kind of, yeah, normal occurrences in programming. Right, so, no, you wouldn't actually see these, you know, when you read the email, but they are included in the transmission. And of course the email program, right, I mean, that is actually going to see them, or yeah, the email client, and of course, well, that, I mean yeah, that's going to see this data, right, in order to parse it, in order to kind of format it correctly, yeah, in order to understand, well, yeah, what's the subject, right, you know, what is the heading, yeah, what's the body, yeah, just to kind of separate the fields, basically. Right, then I guess then if we look, well, then we're going to have some of the common punctuation or symbols, again, you know, you can just have a look at them, it's not really important. Right, so yeah, this one is going to be more important. So sometimes the exam is actually going to include questions that require you to know that, well, 0 has a denary value of 48 in ASCII. Right, then if you remember that, well, then you can figure out the next number, because we say, well, 0 is going to be 48, right, and well, then it's just going to count up. So right, therefore, well, 1 is 49, right, 2 is 50, yeah, of course, etc. And I guess we're going up to 57, which is going to be 9. And of course, if we look at that, we're just going to plus 9, right, so getting... yeah, okay, where's the pen? Right, okay, yeah, getting from 48, which is 0, right, then of course if we plus 9, right, that gets us to 57. And yes, some people get confused about this because they think, well, like, what if we want to do a binary addition? But of course, if we're just doing arithmetic, and let's say, I don't know what, yeah, I guess like the number 4. Alright, yeah, here we go. So let's say the number 4, well, of course the number 4 is still going to be this, right, if we're using it for arithmetic, right, we're, okay, here we go. Right, we're only going to use this representation if we're storing it as text. Yeah, of course, if we're storing it as arithmetic, well, we're just going to use the regular 2's complement. Right, okay, so let's think then, well, with this logic, what would the denary value of 8 be in ASCII? So if you remember what we said, that 0 is going to be 48, right, therefore, of course, we said, well, 1 is 49, right, 2 is 50, and if you count up, right, then you can see, well, 56 is going to be 8. And again, you know, in exams, sometimes I guess sometimes they kind of require you to do that. Then if we look at the next one, which are going to be the uppercase letters. So here, I guess, well, the common ones to know, which is going to be what big A is 65. And again, right, then it's just going to follow the same pattern, right? So just, yeah, counting up by 1. Now, something that you might get confused about is if we say, well, big Z, right, that's going to be 90. And you might think, well, there's, of course, 26 letters in the alphabet, right? Therefore, you would think, well, 65 plus 26 is going to be 91. But if you actually think about it carefully, well, we say, right, okay, so A is going to be 65, right, therefore, yeah, B is 66. And like we're kind of saying, what, if we kind of reset this to 0, let's say like as an offset, so we can say this is kind of like character 0, or the 0th character in the alphabet. Right, therefore, of course, we say, well, B is then 1, and this is, of course, kind of +1, right? Yeah, therefore, what C is going to be, okay, right, sorry, yeah, C is 67, which is kind of, you know, I guess kind of +2 from A, right? Therefore, since Z is the 26th, right, that's why it's going to be, you know, +25, and of course, yeah, +25 is therefore going to be 90. Now, yeah, maybe that's a good definition, or well, maybe that's a good description, or yeah, maybe that's just, you know, confuse people even more. Yeah, so again, all you need to remember is, well, big A is 65, and I guess maybe just remember that you just have to +25 in order to get to big Z, since sometimes they'll actually want you to check that a number, to check that a letter, right, is an uppercase letter, and of course, well, to check its letter, to check that it's an uppercase letter, well, you can just check that the ASCII code is what, greater than or equal to 65, and less than or equal to 90. Right, then if we look at the lowercase letters, again, it's going to follow the same pattern. So, well, A is 97, right, therefore, small z, right, it's going to be +25, right, or 122. So, if we actually compare them side by side, right, the uppercase letters with the lowercase letters, then can you actually notice a relationship between them? And I guess if you probably look at the decimal, right, and also the hexadecimal value as well, and actually the binary value as well. So basically all of them, right, just ignore the oct, or yeah, ignore the octal. Right, so maybe you've noticed that, well, it's just going to be +37. So what to get from the decimal big A, and okay, right, yeah, here's the pen. Yeah, I'm just kind of scribbling everywhere. Okay, right, so to get from the decimal big A is 65, right, and then to get to the small a, it's just going to be +32. Likewise, if you look at the hex, yeah, where are we? Okay, so hex goes from 41 to 61, and then of course, well, yeah, 42 to 62, etc. Right? If you also look carefully at the binary, then you'll notice the binary patterns are also the same, except there's just one difference. And since we're plussing 32, well, that's going to be, right, this bit 6. So because if we think, well, bit 6 has the value 32, right, so of course, yeah, 1, 2, 4, 8, 16, yeah, 32. Right? So if we say, well, in the uppercase version here. Right, in the uppercase version, right, well, they're all going to be 0. But then if we look, right, the equivalent characters in the lowercase version, or yeah, sorry, right, I guess the equivalent bits, right, in the lowercase version, right, of course, well, they're all going to be 1. Yeah, so hopefully that makes sense. And I mean, I think, yeah, this is just kind of saying what I've been saying. And actually, there's a good video by Tom Scott, right? You can go on, well, of course, yeah, I mean, I guess you're on YouTube anyway. Yeah, of course, so just search on YouTube, like Tom Scott, maybe Unicode, or yeah, Tom Scott ASCII. And he actually has a good video kind of just explaining this. And if you think about it, you know, there's actually a reason why they chose this 32 difference. Like, some people might think, well, why don't they just have, you know, sort of big Z, and then just immediately go to small a? But if you actually have this gap of 32, well, then of course it's going to be extremely easy, right? Also extremely fast. Yeah, just to convert between the two. Yeah, of course, you know, to check if it's uppercase, to check if it's lowercase, because all you're having to do is, you know, just change one of the bits. Right? You're not having to do some, you know, yeah, you're not having to do some kind of more complex, more complex addition. Right. So if you actually want to have a go at this, I mean, you can use a website like here. And basically, well, yeah, I guess, you know, well, of course, right, okay, let's say you can just press different keys, and then it's just going to tell you, like, what the actual ASCII code is for that key. And something to note, though, that actually if you press, well, big A or small a, right, so of course, if you've got shift or caps lock selected, it's actually going to tell you 65 for both of them. And I think probably that's just some JavaScript thing, whereas, of course, yeah, what small a should be 97. So, you know, that's the only thing to be careful about. But yeah, otherwise maybe it's interesting, right? Just, you know, press the shift, right, the backspace, the enter, yeah, the delete, you know, just to see what characters they're going to be. And all of those, right, they're all going to be in the non-printable range, okay, since, you know, they don't actually have any output. Right, so if we actually try and, yeah, look at a real file, then, well, I save some text using Notepad and setting the encoding option to extended ASCII. Now, if we note, okay, Notepad actually calls this ANSI, but for the exam, okay, this is just extended ASCII. Yeah, I mean, it's basically just another name, and the reason for that is because, well, really extended ASCII, right, you can actually get slightly different types. For example, you can have, I don't know, yeah, I guess kind of like French. So I know what French has sort of some of these like accents and things. You know, Spanish, right, they're going to have slightly different accents. Yeah, other languages like, you know, Russian, right, they're going to have different characters. So I mean, technically, right, you do actually get different types of extended ASCII. And yeah, I guess, well, this one, right, this Windows one is just going to be a, you know, specific type of it. Yeah, which, well, of course, you know, this is going to be kind of American based, right? Yeah, ANSI, what, American National, right, something something. But again, you know, yeah, when it says ANSI, right, that's just extended ASCII. So if we see this, well, what we can then do, right, we can use a program called hex editor, and a hex editor, I mean, basically, well, you can just load in any, you can load any file into a hex editor, and it's just going to show you the binary contents of that file. Now, if we look, right, it's actually going to show you the contents as hexadecimal, okay, to make it easier to read. Yeah, the specific program I used is HXD, but to be honest, if you just want to try this online, you know, without downloading, you can just search, yeah, kind of online hex editor, right, and there's going to be a few good examples. Right, so here then, well, we see there's 2 bytes in the file, 48 and 69, and note that actually these are going to be hex values, not denary. So we said that, right, extended ASCII uses 1 byte or 8 bits per character. So can you then figure out what the text content of this file would be? So if you think, well, first we actually need to convert this into denary, right? And of course, yeah, likewise the next one as well, right? Then you want to think, well, we said what big A was 65, right? We said what 0 was going to be 48, and then yeah, small a was going to be 97. So if you remember those 3 facts, right, then yeah, after you've converted this to denary, right, then you should be able to figure out, you know, what the actual text content is. So if we just have a look, well, 48 in base 16, that's going to equal 72 in base 10, or 72 in denary, right, that's going to be the capital H. Right, and then, well, 69 in hexadecimal is 105 in denary, right, which is going to be the lowercase I. So of course, yeah, this file, well, it's just saying hi. Yeah, and we see, well, hi, right, it's just going to use 2 bytes since both of these characters can be represented in ASCII. Okay, now let's try saving something like ni hao. So here, well, we're going to use ASCII, right? And what do you think will happen? Because remember, we said ASCII can only represent 256 different characters, right? So basically, if we try and save that, well, we're just going to get this error message. I guess you can read that if you want, but effectively, what that's saying is, well, it's just saying, yeah, extended ASCII only has 256 characters, right? Therefore, of course, yeah, these are not going to be valid ASCII characters. So what we can say is, well, characters, I guess, well, I mean, maybe not most, but yeah, I guess many languages, also scientific, right, mathematical symbols, right, even emojis, right, these can't be represented with ASCII. So of course, well, obviously, yes, some languages, well, I mean, what sort of Chinese, Arabic, yeah, I actually don't know the name of the languages, but I guess some of the languages in, for example, India, yeah, of course, right, many of these languages, right, they're going to use more than, you know, 256 different characters. Right, so yeah, I guess just a challenge. I mean, we won't do this, but you can try. So here, well, let's think, right, what are the contents of this file? And again, it's going to be the same thing, right? So convert it to denary. Yeah, then of course, well, just yeah, convert it to the actual sort of, you know, letter, number, symbol. So here, if we do this, well, it's just going to be 0, right? Then it's going to be big A, right? Then it's going to be small a. So if we look, well, 30, right? Therefore, that must be 48 in denary, right? The next one, because if we look, right, this 0D, 0A, okay, they're actually going to represent the carriage return and line feed, respectively. So if you remember, well, I mean, okay, we say, well, this combination is just going to be a new line. Yeah, that's why we get what 0 and then yeah 0 big A small a, right, just on separate lines. Yeah, and then of course, well, 41, right, that's therefore going to be what 65, and then well 61, right, that's going to be 97, right, in denary. And this is the thing, right, so like maybe people have not done it yet, but if people have done pseudocode, or yeah, when they, you know, come to do pseudocode, right, or yeah, I guess, you know, even a real programming language for A2, then when you're actually reading a file, and okay, let's say when you sort of read the entire line, well, what it's going to do, okay, we say, let's say the file pointer, right, it's going to start at the start of the file, right, then it's just, like basically, well, it's going to get all of the characters, right, or all of the bytes, okay, until it hits this new line character. So in this case, you know, when we go read line, well, it's just going to read this, right? Then it's kind of going to, well, let's say it's going to skip over this new line character, right? Of course, well, then when we call read line again, well, then it's going to look, of course, it's going to get this 41, right? Then here it's going to see what there's another new line. So of course, in this case, it's just going to get 41, right? Then of course, again, it's going to skip over this new line. All right, yeah. Then of course, well, it's going to get this one. All right, well, then of course, it's going to reach the end of the file. Because yeah, I think some people they kind of get confused about like what read file is actually doing in pseudocode, but if you actually look at it kind of under the hood, right, that's what it's doing. It's just reading all of the characters until it sees the new line character, right, then when you call read file again, well, then it's kind of starting from that same position, or yeah, well, sort of skipping the new line, right, then yeah, starting from that position, right, then of course yeah, reading all of the next characters until it sees another new line. Alright, so if we look in contrast then, because, well, of course, right, to offer more than 256 characters, right, because, well, many languages need it, right, then Unicode was introduced. And this can represent all the characters in every language, right, even, yeah, all the mathematical, scientific symbols, right, all the emojis, just everything. And actually, in fact, there's many symbols in Unicode which people don't even know what they are. Because, well, I mean, here it says, right, they're written, in a textbook from 1800, and I guess, well, no one actually knows what they are because, yeah, I guess, yeah, probably the author didn't write it down. But there's even things like, I mean, probably some of the hieroglyphics. They found some, like, cave painting or some hieroglyphic. And, of course, yeah, I mean, well, obviously, I guess, yeah, like, no one actually knows what it is. But since they found it somewhere, they just include it. Right, so currently there's, what, 144,000, and probably this has actually increased, since I made this. Because, well, I think kind of every year they're always adding new emojis and things. And right, the total room is going to be, well, for over 1.1 million characters. So yeah, we're probably not going to run out. Right, then if we look, there's actually, well, 3 different versions as mentioned. So we said, well, UTF-16. Right, okay, so UTF-16, okay, this is always going to use 16 bits, okay, or effectively, what, 2 bytes. And as we can see, yeah, of course, what, 2 bytes, 2 bytes, 2 bytes, right, for each character. Right, then if we look at UTF-8, so we said, well, UTF-8 is going to use between 8, right, for the smallest characters, and then, yeah, up to 32, right, for some of the, I guess, kind of less frequent characters. And, yeah, okay, like, to give an example, of course, we say, hang on, right, okay, yeah, well, this first character is using 3, the next one's using 3, right, and then 3, 3, and I guess, right, this one, just the exclamation mark, right, that's just using 1, right, since it's a common character. Then if we look at UTF-8, well, that's, UTF-32, right, that's always going to use 4 characters. Right, always going to use 4 bytes. Right, so yeah, that's quite wasteful, right, as you can probably realise. Right, then, well, when it says UTF-8, I mean, technically, right, that's the Unicode transformation format. I mean, honestly, like, just kind of ignore those, right, I mean, basically, it's just Unicode. Yeah, and, okay, well, obviously, yeah, for the exam, right, you don't need to remember that name, right, yeah, just call it Unicode. Right, so here then we say, well, all schemes can represent all Unicode characters. So you might be thinking, well, since for example here, it requires 3 characters, you might think, well, therefore we can't represent it. Maybe there's some UTF-16, or yeah, okay, right, maybe there's some characters that we can't represent in UTF-16, right, for example. But yeah, actually that's not true because, well, the way they're going to do it, right, is they're going to have combinations of characters. So you can see this, for example, with, like, say, emojis. Right, where, let's say, I don't know, like, maybe sort of like the family. So if you have, like, a family character, okay, rather than actually having a family character, or yeah, rather than having a family emoji for, like, all of the different types of family, like, well, also, yeah, like, man, woman, like, brother, sister, right, maybe 2 brothers, 1 son. Yeah, of course, there's, like, hundreds of different combinations. What they actually do is, like, basically, well, they're going to go, right, man, right, plus woman, and then, for example, like, plus boy. So, of course, right, I mean, basically, right, well, that's going to be 3 individual characters, but then that's going to be combined to make that single emoji. Yeah, of course, right, of a family, I guess, with, 1 son. Yeah, likewise, of course, if you wanted, 2 daughters in the family, what, say, man plus woman, right, plus girl, plus girl. So, yeah, I guess kind of, like, using tricks like this, right, that's how they're able to represent all the characters. Yeah, even with only 16 bits. Alright, so yeah, let's look at some of the advantages. Now, honestly, like, I would be surprised if they ask this in the exam. Like, they rarely ask about the differences between, UTF-8 and UTF-16 32. In fact, like, I don't think they've ever asked it directly. Although I think in the mark scheme they did actually give you points sometimes, if you could actually kind of hint at the differences. So if we say UTF-16, UTF-32. Well, the advantage is going to be fast to get specific, well, I guess character, or yeah, characters, right, a group of characters. And I suppose, well, also we can call it, what, a substring. And I suppose in A level, what you can say, what it's going to be, well, the left function, right, the right function, and also the mid function, right, if we're talking about pseudocode. Yeah, so if we want to get a sort of, specific character at a range, at an index, right, or in a range, then because of the fixed size, well, it's going to be easy. Because we think, well, let's say the first character, and yeah, where is that pen? Okay, here we go. Well, obviously, well, the first character is starting at byte 0, right, the next character is starting at byte 2, right, the next one's byte 4, the next one's byte 6, the next one's byte 8. So of course, if we say, I don't know, okay, let's say we want to get the 20th character, then if you actually notice, well, right, then we're going to do 19 times 2. And yeah, right, no, it's not going to be 20 times 2, since if you actually look at this, what the first character starts at 0, right, the second character starts at 2. Yeah, so of course, you know, we can just do that simple calculation, right, to work out the specific location. In contrast, if we're using UTF-8, right, this is actually going to be a bit slower, because, well, if we say, okay, we want to get the 5th character, now, like, we don't know, right, because of course we could just have, 5 characters that are 1 byte each, right, or we could be like this, where we have, 3 bytes, 3 bytes, 3 bytes, you know. So yeah, obviously, right, because it's variable length, right, then we have to search through each character, yeah, kind of one at a time, right, until we get to the 5th character. However, right, the advantage of UTF-8, well, it's going to use less space, and especially when working with, I guess, kind of like the common characters, yeah, I suppose, okay, well, let's say at least the characters that are on a standard keyboard. Now, obviously, if you're typing in other languages, right, this is not true, but if you're just typing the sort of, yeah, characters on the keyboard, so yeah, just obviously, yeah, the letters, right, yeah, A to Z, right, the numbers, the common punctuation, right, then it's going to, well, then it's going to use less space. And the reason for that is, of course, well, since we only require 1 byte, yeah, for, you know, for example, like, right, this one, the exclamation mark, since, yeah, actually these characters are just going to be the same as the ASCII code. Right, so for UTF-8, we mentioned our characters can be between 1 and 4 bytes. Right, bytes will start with a fixed pattern shown below, and this is so that decoders, so yeah, I guess, you know, just the program that kind of, well, let's say what converts the binary into the actual character to display. Right, so well, so that decoders can determine which bytes are used for what character, and yeah, I suppose, well, when a new character starts, right, or yeah, when that character ends. So if it's a 1 byte character, well, then it's going to start with 0. Okay, then it's going to have, well, I guess just, yeah, any, you know, any bits here. Of course, right, if it's a 2 byte character, well, it's going to start, yeah, sort of 110, and then, well, obviously the second byte is therefore going to start 11, yeah, obviously, right, etc. for, well, 3 and 4 byte characters. And yeah, actually, like, while this is in the book, right, again, it's never been asked in the exam, but yeah, hopefully people understand what that's saying. So, and of course, again, like, that's why it's going to be a little bit slow to search through, right, because, of course, yeah, we have to search character by character, like checking, of course, what we have to check, yeah, where is this pen? Of course, you know, we have to check what, I guess, kind of the starting bytes, right, in order to determine, you know, which, yeah, in order to, I guess, in order to determine, right, the length of the character. Alright, and then, yeah, maybe just the last example. So let's just try again. Well, let's try, yeah, again, just even Ni Hao, right, this time using UTF-8. And if we see here, so we see actually, and right here it is, so we see, well, the first character, right, this, right, okay, this is going to use 3 bytes. And then, yeah, likewise, well, the next character, okay, right, this is also using 3 bytes. And if you actually look at this down here, well, I mean, yeah, here you can actually see that. Whereas, of course, in contrast, well, when we say hi, well, hi was only using 2 bytes. Whereas, of course, yes, well, saving the equivalent in Chinese, right, is going to use 6 bytes. So just to summarize, we say a character set, this is a collection of characters where each character has a unique binary code. So, for example, well, 0 is 48, A, well, yeah, uppercase A is 65, and lowercase a is 97. Right, then if we look at ASCII, so of course one of the character sets, right, this is older, I think 1963 possibly, yeah, I can't remember. Right, there's going to be 2 versions, the standard or 7-bit ASCII and the extended 8-bit ASCII, and they can represent, well, yeah, 2 to the power of n, right, therefore, well, 128 and 256 different characters accordingly. Right, then there's going to be Unicode, so Unicode can represent all characters, so of course, yeah, like all languages, all emojis, all mathematical symbols, and it's going to use between 1 and 4 bytes per character. And of course, remember the 3 types, right? So, okay, well, of course, right, UTF-8 is going to use between 1 and 4 bytes, right? It's going to be variable length encoding. And that's going to have the advantage of, well, if you're using, let's say, the common characters on the keyboard, well, it's going to use less space, or less storage. However, it's going to be slower to, let's say, find specific characters, right? Slower to search through. Right, in contrast, well, then it's going to be UTF-16, which, of course, well, yeah, it's faster. It's going to use 16 bits. And then, of course, well, UTF-32, right, which, well, of course, is going to use 32 bits. And honestly, UTF-32 is kind of pointless, really, because, I mean, like, yeah, I guess, well, I mean, like, basically, we can represent all the characters with UTF-16 as well. And, you know, therefore, you know, UTF-32, right, it's just going to be wasting this additional space. Alright, anyway, guys, like, hopefully this video is useful. Yeah, I think maybe this content is a bit easier than some of the others. But as always, I mean, if you've got any questions, well, just ask in the comments, and hopefully I'll see you again in the next video.